We're going to train you on clearance and ground using the radar profile we just set up. And then we're going to train you on local using the same radar profile. And then train you on radar using the radar profile. So by the time you get the radar used to it, I don't want you to set up a ground profile and a tower profile. I want you to learn how to control from the beginning like this, where you have this main primary radar display, and then you have a secondary ground control display, and then your handoff. Okay? We might as well get the muscle memory going now. So let's take a look at what's going on each display. So the main display I had mentioned has realistic data tags on. Realistic data tags means a correlated data tag is a tag where the airplane's transponder matches the computer assigned beacon code in the flight plan. An uncorrelated data tag doesn't match and therefore does not display a full data block. You'll get a limited data block showing just the beacon code being squawked. So for example, let me see if I can find someone I can do it to here. So you'll notice I can't click him right there because he's uncorrelated. See that? Nothing happens down here in the radio. So, but if I click on this guy, he's correlated. He populates into the radio here automatically. The computer can recognize him. So let's go ahead and pull one of these guys. Don't worry, I'll explain how I did that in a second. Okay. Now the tower display is not realistic data tag, so you can always see everybody's call sign. So I'm going to pull up the ELB73. And I'm going to assign him a 1200 code, which will correlate him because he's squawking 1200 and the computer is going to have 1200. And look at that. He's correlated now. Okay, now I can slew him. And look at that. I hold control and slew him and it brings up his flight plan, but it also puts him down here in the radio box. Okay, so I can't do anything to this guy. But now I can do something to this guy. I'm holding down the control, I'm clicking him, and then I'm clicking him, and notice the flight plan changes, see that? Okay. Correlated. You'll notice the color is changing as well. Well, here goes a conflict alert happening. The color changed to magenta. Alright, so this is useful for the way we control for situational awareness. When I need to know whether or not I should pretend I can see a target on the ground radar, for example, versus looking out the window. I can see him on the tower, on the ground display, the tower ground display. I will definitely be able to see his call sign and know exactly who he is. But then I'll look over here and see if he's squawking standby or if he's squawking altitude, and I'll act accordingly from there. And I don't need to zoom in or I don't need to do anything. I can see. So for example, up here by Mojave, you see these two guys right here. These two guys are primary targets. That's what the primaries look like in this mode. Both of those guys are squawking standby or transponder off, I'm not sure. So those are primary returns. But the rest of these squares are mode C. All of these squares are mode C. And if he's correlated, then he'll pop up green like this on a 1200 code, or he'll have a full data block. Because we have the quick look on, he'll have a full data block if he's on a discrete code. And you can see what happens when we turn the quick look off. Why do we use quick look? In the real world, you would only use quick look to look at the sectors next to you and around you really quick and then turn it back off. The reason we use it here is because we're controlling all these different sectors, and there's no point in having quick look off ever. I always want to see everything that is tagged up at all times. If I had a split, I still want to see everything. There's not really any time where I don't want to see what's going on in west. So, but you can see, I can see what's going on in west, and I can see what's getting close here coming to San Diego. I don't have to wait for him to push the strip for it to go full data block. All right. So that's important to have that quick look on. The filters is the dimmer. It's just, I played a little trick on it, reversed it to get the colors to work. Alright, so in the radar display, aircraft you're tracking will be green. Actually, aircraft you're tracking will be green, and aircraft that you're not tracking but are actively selected, like this VFR target is right now, or like this guy is right now, will be green. Aircraft you're not tracking and is not selected will be the amber color, like all these guys. This guy and this guy. Well, unless they get conflicted, right? They turn magenta. Alright. And then you see it went away, so it's back to the amber color. Alright, a quick note about the transponders. One of the bugs in our software is all of the simulators only have two transponder modes, off and on. Off will display the primary target that I showed you a second ago with no information, and on will display a full data block with altitude information. Transponders on the real airplanes have at least three modes: standby, on, and altitude. If the transponder is turned from altitude to on, we would still get a full data block but lose the altitude field. In the sim world, altitude mode is full data block and everything else is limited data block. Alright, now we'll run through the button bar up here on the top left corner. You got four tiny little letters here. The tiny bubbles are H for handoff. That'll flash when there's a handoff. C for chat message. That'll flash when you have an unread chat message in your controller list. M doesn't do anything for us. You don't have to worry about that. R is request list. That's kind of an important one. Let me give you an example of what the request list looks like. We just select his call sign here, and that's called ACID. You'll hear me say that. ACID, ACID. So we'll just ACID him by selecting him either by clicking on him or typing a portion of his call sign and hitting aircraft select. I'm slow at typing. There we go. Alright. I'm going to put him on the request list by hitting aircraft select a second time. And there he goes. He pops up on the request list. And you'll get that timer right there tells you how long he's been on the request list, and you'll get a 60-second alert and a beep every 60 seconds. It'll come up here on the radio panel here. Something to watch out for is if you have someone, there goes the beep, if you have someone on that list and they disconnect, like 162 Tango, he's on the ground now. If he was to disconnect right now, he'll be stuck on there, and the only way to get rid of him is I have to disconnect and reconnect to the scope. But there's the flashing reminder up here. Okay, the only way to get rid of him, he has to be selected, and then we aircraft select a second time, and then you get him off of there and he's removed. Alright. Then you have to the right of those buttons, you have the Zulu clock, the position, call sign, and the frequency if I had one set. And we already talked about our filters and quick look. We have a 2-minute timer, a 3-minute timer, and then the data from the last ruler. Alright, moving on, we have the weather panel here. It lists all the airports we cover, and I've added all the altimeter stations for the radar sectors we work. If you've trained on Western US already, you probably know this, but go ahead and click on Catalina and you'll see a METAR with no information. That's the first airport, KAVX. Catalina is an uncontrolled, untowered airport, so they don't have an ATIS. So you'll just see the METAR right here with no ATIS information down here. And you also won't have the letter in the list right there. Now we click on the next one, which is KBFL, Bakersfield. And you'll notice the ATIS info pops up. We still have the METAR, but then we get the ATIS info. Information Lima 0254 Zulu, departing and arriving, runway 30 left, runway 30 right, visual approach is in use, runway 30 left, visual approach, runway 30 right. And up here you see the Lima right there, winds calm. Here in ZLA we subtract 10 degrees from the wind direction for all the airports. It's really between 11 and 13 degrees, but we just round it, obviously. So we're going to say for Las Vegas here, wind 210 at 3. For Long Beach here, wind 300 at 7. Palmdale, wind 250 at 8. Palm Springs, wind 350 at 3. Santa Maria, wind 360 at 4. Torrance, wind 260 at 13. So on and so forth. You get the idea. All right, then the next thing you have is kind of hidden right now, but I'm going to open it back up. It's communication panel. There are two entries. Top one is your primary radio, and this should be set to the position ID and frequency of the position you intend to work. That always has to be set correctly. Both have to match for them to work. Something you need to understand and memorize is if you're logging into the same ID and frequency as another controller, it's okay to prime up before the brief. And if you've worked Western US, that's typically what you would do. Okay? But if you're opening a different position ID and frequency, you must wait for the brief to be completed before priming up. So I'm going to open my controller list. If I was to log in as ZLA 2X on 175.1 to work that position, okay, that's ZLA combined, I could prime up. I could go headset, receive, transmit, and prime up. But if I wanted to get on and work local, which I don't know why this says LC, that doesn't even matter. We could put anything in there. But if I was to come in and work local, ZLA underscore whatever underscore LC, Lima Charlie, local control, then I do not want to prime up, because if I prime up, I will steal all of his local transmitters before the brief is complete. You don't want to do that. That's a big no-no. All right, so if you're opening a different position, ID, and frequency, you must wait for the brief to be completed before priming up. Otherwise, you'll steal the controller's transmitter, and we're going to review this again and again and again and again and again, so don't stress it too much if it's a little confusing. All right, the bottom entry here is identical to the top. We typically use this for guard surveillance, but it can be used for anything a normal radio can be used for. I use it to check the ATIS system pretty regularly. You just center the scope near the airport you want to listen to and type in the ATIS code, and you'll hear what pilots hear. Here's an example using John Wayne. The ATIS frequency is 126.00. So I'm going to open this up. Again, the name doesn't really matter. What matters is that voice.pilotage.net is set, and then the frequency is set. So we're going to go 126.000, save, and then I'm going to hit headset.
5. Visibility 5. Mist. Few clouds at 800. Temperature 18. Dew point 16. Altimeter 3004. Arriving and departing runways 20 left, 20 right. ILS runway 20 right approach in use. VFR departures contact clearance delivery, advise on course heading, altitude, and if flight following requested. Read back all runway assignments and hold short instructions. Advise on initial contact. You have information gulf.
There it is, information gulf. ILS is in use, runway 20 right. Landing and departing runway 20 right and 20 left. So that comes in handy sometimes if pilots say they're having a problem with the ATIS or something like that, or I just want to make sure it's saying the right thing. Sometimes they bug out a little bit and someone complains, so I'll go in there and listen. You also have people who are having audio problems, and they tune up the ATIS to check it, and then they don't hear anything, and they'll come and ask, "Is there something wrong with the ATIS? I couldn't hear it." And that's another way I can go check that. So if you can hear it, they should be able to hear it. All right, so I'm done with that. We don't need that anymore. I can close this. All right, and then the controller and chat window is pretty simple. It just shows all the controllers are on, what frequencies they're tuned to, and what their radar ID is. And you use that to send them handoffs and messages, which we'll talk about later. Here's the arrival and departure list here. All right, when you slew an aircraft or select an aircraft, the call sign, aircraft type and suffix, assigned code, received code, and a mini flight plan will appear at the bottom of the list here. So for example, I could slew 162 Tango here, and we get it. Well, he was already there. Let me slew the other guy. there we go. So 8926 Victor and the mini flight plan populated right there. Call sign, aircraft type, suffix, assigned code, and received code. When they're identical, they combine into one. If you see two codes here, you have assigned and received. That means it's not correlated. So you'll have those data tag discrepancies of an uncorrelated tag. There's his route, or sorry, his departure and arrival destination, his altitude, and his routing. I believe that's his routing. Hold on, let me look at another one. Yeah, that's correct. So departure and arrival, and then the routing there. It just looks funny on this guy because he's got such a simple flight plan. And again, as I said before, I don't use the flight strip bay. I use the mini flight plan for 90% of the radar work. Obviously, on local, when you're cutting clearances and things, you need to use the actual flight strip or the actual flight plan, which is you can pull up using F6, or you can hold the control key and slew the aircraft. Okay. And then we see I got his flight plan in there now, 162 Tango Oceanside 23 Seal Beach. And just remember that he has to be correlated for you to be able to slew him. Slewing is when you click on a target like that. And just as a side note, VS Pro does support key commands if you learn those. So you can go through here like F3. If you were to type F3, it puts in there .qt. If you learn that .qt, you can type that .qt 162 Tango, and it will do the same thing as F3. I use the F keys personally. I also use the right-click functionality. You can right-click on the data block, and you can right-click on the beacon symbol, and you'll get this context menu. You can start track, assign squawk, toggle full data block, so on and so forth. You won't be able to toggle the data block because we're in quick look, but you get the idea. You can clear temp altitudes, clear scratch pads, so on and so forth. Toggle the reminder. That's the request list, and your R is blinking. And I'm going to toggle that again. Okay. You can get weather for his departure or his destination right there, and then it'll put it down here at the bottom. You can set an anchor, clear an anchor. Set an anchor allows you to type a fix. And so if I type Seal Beach, enter, it sets the anchor to that. And then I can do clear anchor again, or we can do that the other way. We can do .an. And then we do no anchor. Plural, no anchors, sorry, no anchors, plural, and that clears all anchors. All right, there it is. And I don't know if you just noticed, I'm scrolling through my previous commands by using the up arrow down here. So if you look, it makes it easy to pull stuff up that I just did and repeat it. So I can go through the previous commands going up and pressing the up and down button. I can also make the radio bar bigger or smaller by holding the control key and using the up and down arrows, if you're not familiar with that. So if you want to see more of these lines, I tend to like to have a lot of lines up there, about 12 lines I use. All right, so we have the small handoff screen down here. You can see the effect, how it works here. This Southwest would have been flashing at us, and I would just come over here and just start a track on him without having to move from here. I could be down here vectoring the final or whatever, you know, pick up a handoff and then move on about my life. All right, it overlaps the western U.S. border by about almost 100 miles. So you pretty much see everything all the way around. We did talk about the full flight plan window here. It's where you send DCL clearances. You can read the remarks. and edit any of the flight plan information and read any of the custom server messages that'll be at the bottom. We'll go over the computer codes later. Just remember where to find them. It's right down there. You see this right here in the brackets. That's a computer message. And then the only thing left here is the local display. Again, I use this to control traffic on the ground or in the tower airspace. You can see I can put my mouse over it and then use my mouse wheel to zoom out if I need to see the airspace. Again, it's set to unrealistic data tags so I can interact with anyone and see anyone, and which is kind of necessary in the tower environment. You look out the window and you can see the guy. You're not blind just because he's not on the right code. So you can always see and interact with the data tag regardless of the transponder status on this screen. And we have shortcut codes to be able to access this screen to be able to recenter on other airports. To do that, you'll want to memorize this. You type .2 and the 3-letter airport code. Okay, that's for screen 2.2. You could do the same thing on screen 1 using .1. So if I do .1 and I go Bakersfield, which is BFL, I'll go .1 and see it recentered screen 1. So you can kind of toggle between, let's say you have a guy on approach in Bakersfield and you got to have a guy on approach in Palomar. I can kind of toggle that without dragging it. There's Palomar, CRQ. There's Bakersfield. If I want to look at the ground, okay, so I can look at Palomar ground using .2 CRQ. Okay, we can see this guy just taxied to the ramp. And look at San Diego Lindbergh, Montgomery. And you can see this traffic is over top of the Delta. The Delta is at 2900. He's up there at 44. And just for repetition, again, the .2 and the 3-letter code. You can see the 3-letter codes in your weather panel. They're all there. I'm going to pick Burbank this time, BUR. And it updates the airport to BUR. You can also see that on all these airports I'm selecting, the parking text and taxiway text is on. Taxiway labels are like Delta right here, taxiway Delta, taxiway Alpha, runway 26, runway 8. Okay, but there's also parking. You have to zoom in a little further to see it and kind of look because it's dark to stay out of your way. But here's Terminal A at Burbank. Come over here. There's Millionaire right here. And there's Atlantic right here, for example. And we have every airport is labeled that way. Here's Santa Barbara. Here's the terminal. FedEx. Helicopter. Signature. I believe it says FAA, no, Santa Barbara Administration. And the fire stations right there. Notice this color of this square, this brightened color. That's the tower. You'll see that at every airport. I'll show you some more, but before I do, I want to show you another important feature. Notice the color of this runway and the color of that runway. That runway is dim because it doesn't have night lights. So you can't use it after sunset. It has no lighting. This one has lighting, so you can use it after sunset. I do want to change the color of the tower because it makes it almost look like a helipad because it's the same color as runway lighting. But they're typically a small little square or rectangle. Let's look at a couple real quick. There you go again. That's the tower. There's the tower. It's pretty obvious. There's the tower. Alright, on this display I don't have any room for my browser. So if you only have one monitor, good luck. But if you have more, then you would have room for browsers, open up PDFs and charts and things of that nature. You'll want to have some kind of space somewhere, a second computer, iPhone, something, to be able to open up some charts. It's best to have it on the same computer because then we can use all the different alias codes to get to that. All right, so real quick, we'll go over some notes about the software. The network simulates radio reception based on terrain obstructions and transmitter range. So you'll get static when an aircraft is moving behind obstructions or is getting too far on the frequency it's on. If COM2, we talked about this, if COM2 is not assigned in a push-to-talk, a unique push-to-talk, COM1 will not function. Another bug, the software uses ground speed reported from the sim. So this 120 you see here, that's the speed reported from the airplane, which is not realistic at all. The aircraft's actual speed should be calculated by the radar return, which is how a real radar calculates speed based on the movement across the ground on each radar sweep. But this uses the airplane's ground speed, and it causes some weird problems when they're having like frame rate issues or anything like that. If the pilot's having slow frame rates or uses some time compression, the actual speed of the airplane will change, but the ground speed that's displayed will not. So that can make it hard to predict separation. That also affects all your anchor tools and separation tools. They all calculate using the displayed speed. And on that note, pilots should not be using time compression without ATC permission. Pilots can set custom weather in their sim that's different than reported by our weather stations. That should be marked as a CW in the remarks. Pilots can pause at any time, but they should not without permission. If it causes a traffic issue, we can remove them if it's inconveniencing another pilot or causing a separation issue. If not, you can just leave them there, let them pause, and when they come back, tell them, hey, don't pause without ATC permission. Movement on the ground, some of the simulators, or all of the simulators, have the ability to reposition. It kind of looks like teleportation. But pilots are required to get permission before they use that, before they teleport around the airport, if they're going to be teleporting around on movement areas. However, there are several pilots who have flown with us who have special needs or software limitations that require them to reposition. So if you're working one of those, clear traffic out of their way from the desired point, and then issue a clearance as you would normally. I like to use plain English phraseology, so there's reposition to runway 25 at Alpha is approved, and then go from there. Another issue, aircraft using real temperature aloft will display the wrong altitude. Let me see if I can find one. This guy might be one. He's 400 feet off. And Southwest already started descending, so I can't tell. But you'll get a reading that can be up to as much as 3,000 feet. So keep that in mind. Keep everybody 1,000 feet away from the altitude that you see displayed. So these are just some of the bugs. I'll give you this in text as well. All right, that's the setup and the basics of the software. And we'll start getting into the training in the next videos.